In this lecture, we're going to show you that you can pass your template type parameters by reference. And we're going to look at a simple example to really drive this home. What we have seen so far is that we can do things like this and specify our T like this. And this is going to generate a template instance that passes arguments by value. For example, if we pass in double A and double B here for our maximum, we're going to generate a template instance which takes double as parameters and returns a double here. And this is going to be doing things by value. Okay, this is what I want you to focus on right now. It is that this is going to do things by value. So if we go in our function here and compute the maximum, you're going to see that the addresses we have on the outside are going to be different from the addresses we have on the inside here if we try to print them out. But you can also pass your template parameters by reference. And the syntax to do that is ridiculously easy. You just use this like you would use any reference. We say const t reference here. And this is going to just replace in whatever type that you pass when you call the function here. For example, here we are passing in double arguments. So this is going to deduce a double template instance, which basically says const double reference maximum, const double reference A, and const double reference B. And this is going to be the function that is called. So this is going to really do things by reference. And the values we have inside our function template body here are going to be true references to the values we have on the outside. If we happen to do any modification inside the body of the function, the modification is going to be visible on the outside. What we're going to be doing in this lecture is just printing the addresses here, and we're going to see that they are the same here on the outside and inside the body of our function template here. Okay, this is what we want to really play with in this lecture. But before we head over to Visual Studio Code, I want to show you that you can confuse your compiler if you are not careful. If you set up these two function templates you see here, they are going to be overloads, and we can use function overloads with templates. But for now, we're just going to focus on the parameters that we are passing in here. The first one is taking things by value, and the second one is taking things by reference, as we see here. And if we issue a call like this, we're going to have the same problem we have seen with function overloads before. This is not going to know whether you are calling by value or by reference, and this is going to cause a compiler error. I really want you to be aware of this. Okay, now that you know this, we're going to head over to Visual Studio Code and really play with this a little more. Okay, here we are in our working folder. The current project is template parameters by reference. We're going to grab our template files and put them in place. So let's do that. And we are going to open this little guy in Visual Studio Code by dragging and dropping here. The folder is going to open up. We're going to open it, and we're going to close the left pane here and clean up our main file here. And we are going to put in our function template. One thing I want you to see in this lecture is that it is possible to separate these things into function declaration and function definition. Let's just try and do that here so that you can really see this. And then you're going to have to choose what you like a little more. So let's grab our function header here and use that as our prototype. We're going to put that in front of the main function, and that's going to be our declaration. And if we go down after the main function here, what we have is our definition. This could work, and this is going to generate template instances for the calls we do in the main function here. Okay, now that we have this, we can head in the main function and really play with the function template here. We're going to set up two double parameters, and we're going to call the function. For example, we say auto result, and we're going to call the maximum function, and we're going to pass in A and B. This is going to do default template type deduction, and it is going to generate a double function template instance here. But what we really want to prove is that this is going to pass things by value. And one way we have to prove this is to print the addresses both on the outside and on the inside of the function here. You see, we are already doing that in our function template body. We are going to print the address of A. So we can really grab this and reuse this stdc out statement. And we are going to change it to say out here. And we're going to print the address of A. Let's grab this again and use this after the function call. And what we expect to see is some address on the outside So for example, we may have something like 0x and 111 ABC, which is some hex number here. And that's the same thing we're going to have on the outside, because the value we have before the function call and the value we have after the function call are going to be living at the same address. But what we have inside the function body is going to be a copy. So it's going to live at some other address, for example, let's say DA. And the main point here is that what we have on the outside is going to be different from what we have on the inside. And hopefully this is going to prove that we are passing by value. So let's print out our maximum here and see the addresses printed out. We're going to build with GCC, and we're going to build successfully. We can bring up a terminal to play with us a little more. We can clear and run Rooster. We're going to see that the address on the outside ends in DD8, and the address on the outside ends with DD8 after the function call. But inside, you see that we have a different address. And this is going to tell us that we are passing by value, and what we have inside the body of the function is basically a copy. Again, I don't expect you to see the same addresses as me here, because your operating system is going to set up the addresses however it wants. The main point here is that the addresses you see on the outside are going to be different from the addresses you see on the inside here, and this proves that we are passing by value. But what if you don't really want to pass by value and make your function template work by reference? Well, we can do that. We can change our function here to do things by reference, and all we have to do is use t-reference like this. Okay, and when we start using references, we really need to be careful and make sure people don't modify things without our knowledge. And a good practice is to mark your things as const references. So we're going to do that. And we are going to do the same in our function definition. So we're going to change this to const t-reference. Let's do that. And I'd say const t-reference for the first parameter here, and say the same for the second parameter here. And this should be it. We shouldn't be able to use this reference to modify the data inside the body of the function, and our function is a little safer. But what the compiler is going to do is really what it's been doing all along. It's going to look at the arguments that we pass to the function call here. It's going to see that it is double, and it's going to do default template type deduction. So it's going to generate a double template instance for the function template here, and it's going to replace in double, and we're going to have const double reference maximum, const double reference A, const double reference B. And we can prove this by going into CPP Insight. I think we can do that. So we are here in CPP Insights. We can take out whatever we had. We're going to put in new code here, and we can hit the run button to generate our instances. And here we have our template instance here generated. You see that it is going to generate a double version of our function template here. And this is what we have. So const double reference maximum, and it is going to put in a double explicit argument here, but this is business of the compiler. What we really care about is that it generated a double template instance for our function template here. Now, if we run this, it is going to be passing parameters by reference, and what we have on the inside should have the same address as what we have on the outside here. So to really drive this home, we should change our address to ABC to comply with what we have on the outside here. We can try and build our program. We're going to use GCC to do that. The build is going to be good. We're going to clear. And if we run Rooster, we should see the addresses being the same. Out DE0, in DE0, and out DE0. And you see now we are passing our parameters by reference. And if you want to set up a function template that passes template parameters by reference, this is how you can do this. And I think we can also try and debug this and see if we can see any more information on how this works. We're going to hit our run tab here, and we're going to hit the green button to start debugging this program. We're going to be using the debugging tools from GCC, and we see our local variables here. We have hit the breakpoint, and we have the main function to the top of the call stack. This is what we have here. And if we try and step into the maximum function, we're going to see that the template instance now is using const double references, and this is the template instance that was generated. I think this is all we can really see here, and let's stop this and show you one last thing. What I'm going to show you is that you can't really have the function template that passes by value and the other one passing by reference. If you do that, you're going to have problems when you issue the code like this because the compiler is going to be confused. Let's change the second one here to pass by value. So we're going to remove the const reference here. I think it's going to do. Let's do that pretty quick. We'll remove the const and the reference. We remove the const and the reference here, and we use this guy as our function prototype in front of the main function here. And how can we say that? We're going to go on top here and say that. Okay, we're going to put our semicolon, and this is going to be our declaration. But the moment we do this, you see that our compiler is going to be confused because we have two possible candidates for the call here. It can either be by value or by reference. And if we try to build this program, we're going to get a compiler error, and it is basically going to be saying what is wrong here. So it's going to say call overloaded maximum double ambiguous because we have two candidates again, one by reference, one by value, and this call can be surfaced by both of these candidates here. So the compiler is going to give us a compiler error, and we have no choice but to use either of these two, but we can't have them all in our code. And for example, if we take out the one by value here and leave in the one by reference, so let's comment this out again. If we build, we're going to build. You see the build is good, and we're going to print our data. However, we have it in our code. We see the addresses are the same. And another thing I don't think I really proved to you is that we are passing by const reference here. So the template instance that is going to be generated is going to be passing by const double reference because we are passing in double parameters. But because of this const in front of our arguments here, we want to be able to modify the data referenced by this name here. If we go inside, for example, and say ++a, try to modify a in any way through this reference, we're going to get a compiler error. Let's build again, and we're going to see that. And build finished with an error. And it is saying increment of read only reference a because we are passing by const reference here. So you should really remember this, even if we are doing things in the context of function templates. This is really all we set out to do in this lecture, showing you that you can set up function templates that take parameters by reference, and contrasting this with passing by value and seeing the differences between these two things. We're going to stop here in this lecture. In the next one, we're going to learn about template specialization. Go ahead and finish up here and meet me there.